Hi, I'm Jack Hansen. Let's skip the small talk. Each time that you access a website, make a search, or really do anything on the internet, you're creating massive amounts of data that's being collected and sold. The amount of data we create is incredible, and it's showing no signs of slowing down. To give some perspective, your average computer can hold about 500 gigabytes. Your pitiful computer holds about 1/1 billionth of a zettabyte. And if our data generating trend continues, by 2020, there will be more bytes than there are stars in the observable universe. So, what exactly does this mean? Are our computers going to explode from how much data is being created? What do you even do with 5 zettabytes? How do you make sense of it? Well, machine learning. Most companies employ huge banks of servers that use a form of machine learning to parse all that data and make it usable. Before we dive into how machine learning works and has changed the way we think about data, let's talk history. In 1950, Alan Turing designed the Turing test to determine if a computer has real intelligence. By the Turing test standards, a computer is deemed intelligent if it can deceive a human judge that it is human itself. Just 7 years later, Frank Rosenblatt invented the idea of a perceptron, which emulates the neurons in a human mind. This revolutionized the field of artificial intelligence by allowing learning algorithms to learn by experience rather than by programmer input. Fast forward, it's 1981. Gerald de Jong introduces the concept of explanation-based learning. I don't really have a visual for EBL, so enjoy Boston Dynamics' Spot falling on a banana. Explanation-based learning allows machine learning algorithms to look at a situation with many variables and determine which are important and which are not. This is a huge leap because it allows algorithms to essentially focus on what's important. This is analogous to how humans think of things. When you're going to the fridge to get a soda, you don't focus on where the dining chairs are or where your parents are. It's unimportant to the task at hand. Explanation-based learning gives programs that same insight. In the 1990s, the way machine learning operated shifted from a knowledge-driven approach to a data-driven one. We moved towards analyzing huge chunks of data and drawing conclusions from the results. This is a very important jump, because as we were talking about earlier, around this time is when all the data really started accumulating. This step forward allowed programs to not just learn as they go, but to study on prior data that's been generated. Before this change, it was kind of like being unable to study for a test. Now that we've covered how it started, how does machine learning work? Machine learning is a very, very wide field, so today we'll focus on artificial neural networks. In the most basic sense, an artificial neural network, or just neural network, functions like this. You start with an amount of data, inputs, and outputs to train with. You're trying to train the neural network to give you the correct output from the given inputs. Let's create a semi-functional example. Here's the table of data we're going to use to train the neural network. x1 and x2 will be our inputs, and we should expect to get the output as shown in this table. Can you see the pattern here? Whenever x1 is 1, the output is 1. This is essentially what we're trying to teach our neural network. Let's lay out our neural network now. Okay, now let's use it. We start by inputting x1 and x2 from our table, and then they are multiplied by a weight. Each input has its own weight, in this case W1 and W2. These two weights are then summed in our neuron and then passed on to an activation function. The activation function is essentially an on-off switch that is activated or deactivated based on the sum of the weights. How big or how small the sum has to be to trigger the activation function is entirely dependent on the programmer writing the neural net. Okay, so now we have a completely useless net that will probably just spit out garbage. How do we fix that? Well, we need to train it with our dataset. Training a neural network is essentially adjusting the weights via an algorithm until the desired result is achieved. In our specific dataset, we would want W to be 1 so that when it's multiplied by the input x1, it stays the same, and W2 to be 0 so it essentially ignores the second column of our table. This is just scratching the surface of artificial neural nets. Most nets have tens of thousands of neurons in all different kinds of arrangements for different results. And this is only the beginning. Artificial neural networks are still in their infancy. Who knows? Maybe one day the robot overlords will rule over us after all. I hope you enjoyed this video. Thanks for taking the time out of your day to watch it. Have a great day.